So just a second ago we learned how to identify and write. Now we're going to solve a system of two equations. And notice that this says, what is the solution of the following system using matrices? So first we need to set this up in a matrix equation. So it's x, y equals constant. Let's always make sure that's true. So it's 5, 3. -4, -2. My variables are x and y. And my constants are 4 and 3. So in order to solve this, I need to get x, y by itself. Okay? This is all multiplication. So I have to undo this matrix. Okay? So what we're going to do is we're going to find the inverse of this matrix, and we're going to multiply it to both sides. The inverse will cancel this out, making the identity, okay, leaving the variable matrix. Okay, we had this in our notes. So we have a times x equals b. We're going to multiply both sides by the inverse of a. Notice they're on the left. Okay, has to be on the left. A inverse and a make the identity. Identity is 1, 0, 0, 1 and the 2 by 2. And then identity times anything is just that anything. So in other words, we have to find the inverse and then multiply it on both sides on the left, and that will solve the equation for us. Okay. So how do you find the inverse of this? Do you remember? First, we need to determine if it has an inverse, right? And so what is the determinant? Let's let this be matrix A. Okay. So what is the determinant of A? You remember? Yeah, you take 5 times -2. And is it plus or minus? Minus. And then 3 times -4 is -12, which is the same thing as -10. 2 negatives make a plus 12, which is 2. So yes, I can find the inverse. Okay? So now I need to find A inverse. How do I find the inverse of this matrix? You switch to 5 and a -2. Good. Change the sign of -4 to 4 and 3 to -3. And then I forgot, I should have put this on the left. But do you also remember you divide by the determinant? I'll just put it here. Okay. Okay, this is usually right there. It won't make any difference in this case. So I need to take each of these numbers divided by the determinant, which was 2. So the inverse is really -2 divided by 2 is -1. 4 divided by 2 is 2. And then -3 divided by 2. And 5 divided by 2. What I'm going to do is I'm going to put this matrix on the left. Okay? So I'm going to add that in there. Remember, whatever you put on one side, you have to put on the other. So I'm also going to add this matrix right here. So I had my matrix equation, and all I've done so far is I put A inverse in front here and here. Okay? So I put this matrix in front on this side and this side. Because whatever you multiply on the left, you have to multiply on the right. Okay? Now, because we found the inverse, we already know that this matrix times this matrix is the identity. The identity being 1, 0, 0, 1. And we know that 1, 0, 0, 1 times xy is just xy. Okay? So this cancels out this, leaving xy. Okay? It's like having a 1/2 and then 2. 1/2 times 2 makes 1. And 1x is just x, right? So those cancel. And now I have to multiply this matrix times this matrix. Notice it has 2 columns, this has 2 rows, so I can multiply them. You do row times column, so it's -1 times 4. So -1 times 4 is -4, right? And then 2 times 3 is 6. -4 plus 6 is 2. And then you go to the next row, -3/2 times 4. You may have to write that one down. So I'm taking -3/2 times 4, and then plus 5/2 times 3. Okay. So this is really -12 divided by 2, -6, right? Right? And then 5/2 times 3 would be 15/2. You know one thing you can do if you don't like fractions? Yeah, you can just type this in. Because I don't want you guys to get stuck on the fraction part. So -3 divided by 2 times 4, because I know it's kind of hard to see. See it? Can you see that? I don't know what's up with the lighting. And then plus 5/2 times 3. Now I got 1.5. Okay. See how I did that? I just typed it in. And then you can even change it to a fraction if you really wanted to. Math, enter. We'll change it to a fraction, 3/2. So what that tells me is that x equals 2 and y equals 3/2. Now I want to double check my work. You don't have to double check your work, but I want to go back to Algebra 1 and remind myself how to do this by hand. I don't expect you guys to follow along. I know it's been a couple years, but you should know how to do this. You don't? So I'm just going to solve it by hand, double check my work. You don't have to do that part. So this is review from Algebra 1. You don't have to do it this way anymore. Guys. So you may remember elimination. Elimination, you want one of the variables to be opposite. And so I'm looking at the y's, that would be the easiest to make opposite. So if I multiply this by -2, I get -6x plus 4y equals -6. And then I bring down the top equation. And then you add them. Remember doing this, elimination? From Algebra 1? These cancel. 5x plus -6x is -x. And 4 plus -6 is -2. So x is 2. Now that you know x is 2, you go back to the original equation. And you plug 2 in here. because x is 2. So you get 10 minus 4y equals 4. That's an algebra 1 two-step equation. Subtract 10 from both sides. It's negative 6. Divide by negative 4. That'd be what? 6/4, which equals 3/2, which equals 1.5. Okay. So I double check my work, right? And so what that means is there's two lines, and here at 2, comma 1.5 is where they intersect, and that is what we call the solution. Okay. So we have x equals 2, y equals 1.5 on the back. We had x equals 2, y equals 1.5. Notice it's just a different way of doing it now. Okay. And so I want you to try this one yourself.